Once again, welcome to a new problem. This time we have a bone, which is a femur, and it has a cross-sectional area. So if you cut through right there and then you peek into it, you're going to see that the cross-sectional area A is given as 3.0 centimeters squared, and we can always change that to meters squared by saying this is meters squared over 100 centimeters times another 100 centimeters. And that's going to give us 3.0 times 10 to the negative 4 meters squared. That's the cross-sectional area of the bone. We want to find out the compressive force before the bone breaks. That's what we want to find out in this problem. We do know that stress, if you're applying a force on the bone itself, maybe there's a force being applied on this side F, it's going to be undergoing stress at the cross-sectional area, and so stress, sigma stress, is giving us the force applied over the cross-sectional area. This is the force, and that's the stress, and then this is the cross-sectional area. And so if we want to find the force, we can reorganize the problem to see that the force is the stress times the area, or the compressive force, if you want to call it that. This is force, it's compressive. It's the compressive force. And so we plug in the numbers. The stress for the compressive strength, the compressive strength for the stress, the stress of the bone is 170 times 10 to the 6 Newton per meter squared. That's the sigma, and then the area, as you can see, is 3.0 times 10 to the negative 4 meters squared. And so if you simplify this problem, you get that the force itself becomes 5.1 times 10 to the 4 newtons. So again, our goal was to determine the compressive force, given that the stress that it can take is 170 times 10 to the 6 Newton per meter squared. The cross-sectional area is 3 centimeters squared, and we transform that to meters squared by conversion units. These 2 centimeters are going to cancel that out, and so our formula becomes meters squared. Hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks.